Okay, I'm not going to write down the complete two-column proof here, and I'm going to refer to some of these triangles with Roman numerals instead of the 3 letters. And you probably have to pause the video and write some of the stuff down, but here we go. Here's some things to think about. If triangle 1 is given to be isosceles with vertex angle A, that means that AG equals AB, so I put 1 tick mark there. And if triangle BCD is told to be isosceles with vertex angle C, I've got 1 tick mark here already. By the definition of isosceles triangle, DC can be marked with 1 tick mark also. And then base angles of an isosceles triangle are congruent. So I can put these blue tick arc marks here. And you should now see that triangle 1 is congruent to triangle 2 by angle, angle, side. And if you wanted to, you could conclude that the vertex angles are congruent and say triangle 1 is congruent to triangle 2 by side, angle, side. Okay, so now we can put these 3 green tick marks on BD and BG because corresponding parts of congruent triangles are congruent. HB is congruent to itself by the reflexive property. So we need one more congruent piece. I don't see anything that will give us congruent angles for the 2 target triangles, but I do see down here that perhaps triangle 3 is congruent to triangle 4. Because looking at this diagram, I've got these double arc marks. This is an equilateral triangle down here, triangle GFE. So all corresponding sides are congruent. So I can put 2 tick marks there on GE. ED already has 2 tick marks. The angle between HE and ED has 3 arc marks, and between HE and GE, 3 tick marks. So, and HE is congruent to itself by reflexive. So triangle 3 is congruent to triangle 4 by side, angle, side. And that allows us to put these 4 tick marks on GH and HD. Now you should know the reason that triangle BHG is congruent to triangle BHD. Got everything marked that you need. So there you go. Hope that helped. If you have any questions, post a comment.